Alright, this is our Chapter 6 review. The first few problems have to do with the polygon angle sums inside and outside. The question one actually talks about the exterior angle measures. And remember how we talked about how we know that no matter what the polygon is, the exterior angles always have a sum of 360, no matter what. And so if they tell me that one of the exterior angles is 30 and I'm looking for how many sides, I'm just going to divide by 30. And what's that? That's like 12, right? So it's a 12-sided figure or a dodecagon. Number 2 tells me that a non-regular hexagon, right? So that means it's all wonky, none of the sides are congruent. It has 5 exterior angle measures, and it gives you those 5, and it says what is the measure of the interior adjacent to the exterior angle. So again, what they're asking for, and we all know that Miss Wyndham can't draw hexagons, so it's saying that if we have a hexagon, that's a pentagon. What am I doing? We have a hexagon. Let's try this again. But of course, it's not regular, which mine probably isn't anyway, and it gives you 5 of the exterior angles. Y'all know how I like my pictures. So it's giving me 1, 2, 3, 4, 5. So those are the 5 numbers they give me. They don't give me the 6th one, and it's asking for the measure of the interior angle that's next to the last exterior. So if this one's the last exterior angle, they're asking what is that interior angle next to it. So we're just using the same thing that we did on number 1. We know, first of all, that they have to add up to 360, so that's the first thing I'm going to do. I'm picking up my calculator, and I'm adding up 55 plus 58 plus 69 plus 57 plus 55, which is a total of 294. That's the total here. Again, they have a sum of 360, so I'm going to be doing 360 minus 294. So let's see. So that's 66 degrees. Now that's the measure of the angle that's outside. What they're asking for is the measure of the angle that's on the inside. Make sure and read the problem. We know that these two make a straight line, right? So if one is 66, 180 minus 66, my answer is 114 degrees. Let me highlight these answers. There's the answer to that one, there's the answer to that one. All right, 3 and 4 are the sum formula that we did, right? We talked about how we know if we want to know the measures of the interior angles, we have to figure out how many triangles there were. And that's always 2 less the number of sides. And of course, we know triangles always add up to 180. We talked about that in class. So if I wanted the sum of all of the angles, so in this case, the 35 gone, I'm just going to do 35 minus 2 times 180. And that is going to be 5,940. So that's the sum of the angles of all of a 35-sided figure. Whereas, that's the same color. Whereas in the next one, it's asking for one interior angle, and notice that it says that it's regular. So that means that we know they're all the same, unlike number 2. So I'm just going to use the same formula, right? And I'm going to do 30 minus 2 times 180. What is that? So that is 5,040. Again, that's the sum for all of them. And then I want to divide that by how many sides there are, which of course is 30. And I get 168. So one angle in a 30-sided figure that is regular would be 168 degrees. So that was all from lesson 1. It might not hurt to go back and look at that. All the rest of them, quite literally, are, hey, look at all these quadrilaterals that we learned. So it might not be a bad idea to have our characteristic sheet out. So let's look at number 5. Number 5, this is a kite, and I can see that because it shows me the 2 consecutive sides are congruent. And what we actually had one similar to this yesterday, where we know that this one has to be equal to this one, right? They're in between those 2 non-congruent sides. And I know that in a quadrilateral, they all add up to 360. So the first thing I'm going to do is I'm going to add 96 and 74. I could probably do that in my head, but not today. It's been a long afternoon. I get 170. wow, this is really, oh, God, duh. So we know that they all four add up to 360. So then I'm going to subtract. So 360 minus 170. It's going to be 190. And now that's both of them. This one and this one together equal 190, and we know they're congruent. So I'm going to just divide that number by 2. And I get a total of 95. So the missing angle for number 5 is 95 degrees. Number 6, this is just a trapezoid. And we learned that in an isosceles trapezoid that the consecutive non-base angles are supplementary. So it's just going to be 180 minus 60. So my answer is 120 for this one. That was one of the properties that we wrote in for an isosceles trapezoid. Number 7, we had one like this yesterday. Finding the mid-segment is what that side was called, here in the middle. And remember, it's just the average. So you're going to add the two bases, divide by 2. Oops, I don't know what went on there. Let's change that. Divide by 2. And of course, you're going to get 11 for this one. All right, number 8, we do have a little bit of algebra, but a tiny bit, not too much. We go, so this is supposed to say that this is a parallelogram, and on the test tomorrow, it will definitely tell you that it's a parallelogram, because I know I've harped on, please don't make an assumption. And so in a parallelogram, we know that the adjacent angles are supplementary, and that's what Z and Y are, right? Z and Y are adjacent angles, they're next to each other, so they have to add up to 180. So if you think about that, that means if this side is 80 degrees, then this side has to be 100 degrees, right? Because they add up to 180. So if I had 11x minus 10, that would have to equal 100 degrees. So that gives me a pretty little easy problem to solve. You would add 10 to both sides. We did one real similar to this the other day. This one's not too bad. It's just a two-step equation. And you get 110. Of course, if you divide both sides by 11, you're going to get x equals, 10. So that is the value of x for number 8. Moving on now. Number 9, again, I totally meant to put what these are, and it will say so on the test. This one is also a parallelogram. And in a parallelogram, we know that the diagonals bisect each other. So if I were to tell you that Km is 23.4 and I ask you for Y to M, I'm just going to divide it by 2. So 23.4 divided by 2 is 11.7. So the answer from number 9 is 11.7. Now, number 10, they don't have to tell me what it is because it is marked. I can see that it is a rhombus because all four sides are congruent, which means that even though they don't ask for it, I know this one down here is 106, but I also know like this is equal to this, right? And this is equal to this. They're all equal because it's a rhombus. So I'm just going to take, I'm going to use the fact that we know that this is a triangle. And yes, there's more than one correct way to do this one, but it's just the shortest way in my mind. So I'm going to do 180 minus 106, which of course is 74, which means that this angle and this angle, right, since we know it's an isosceles triangle, they have to be congruent. So 74 divided by 2, and then again, just to be on the safe side because I know my brain's not working, 37 degrees. So the missing angle for number 10 is 37 degrees. Number 11, same thing. They don't have to tell me it's a rhombus. I know it is because of how it's marked. They tell me that EK is 9 and that FD, so that's this whole length here, is 22. They want me to find the length of DE. So hopefully it's obvious we're going to do the Pythagorean theorem because we have done it so many times. Like we know in our rhombus that this is going to be a right angle, right? The diagonals are perpendicular. That was one of our properties. If from F to D is 22, that we know from K to D has to be 11 because the diagonals are also being bisected. And I'm looking for the hypotenuse here. So this would be 9 squared plus 11 squared equals DE squared, or whatever. If you wanted to use C squared, that's fine. Let's see, 9 squared. It would help if I use my calculator correctly. Sorry. Well, squared, there we go, plus 11 squared. That's 202. And of course I know I'm going to take the square root of 202. So that's what we get. About 14.2. I'm rounding to the nearest tenth. So that would be the length of side D. Number 12, I am going to give you a picture, and I want you to give me the most specific name for it. So you have your sheet there, and you're going to see, you know, what's equal, what's not equal, what's maybe something's being marked as being bisected. And so for this particular one, since I can see that the opposite sides opposite angles are congruent, and I can see that all of the sides are congruent, right? You can see that they're all 12.9. But obviously these aren't right angles, so this one has to be a rhombus. So that's what I'm going to be looking for, is like the most precise name. Yes, it's a quadrilateral, yes, it's a parallelogram, but most specifically, this particular one happens to be a rhombus. And that, guys, is your chapter.